It's Mr. Thompson with a science video lesson. Today, continuing on with physics, and we are talking about Newton's first law and also forces. Bit of an introduction to forces. So, here we go. Newton's first law says an object's velocity will not change unless it is acted on by an outside unbalanced force. Okay. What does that mean? Well, we'll kind of get into this as we go throughout this video, what this means. But there's another way that this often gets said, and it gets broken up into two statements. The first one is an object in motion tends to stay in motion. Okay, and also an object at rest tends to stay at rest. So object in motion tends to stay in motion. If something's moving, you have to work to stop it, usually. Okay, now we'll get into sort of more specifics. You might be going, not sure about that, but just keep that. But if something's moving really fast, it's hard to stop. Imagine a car moving. You have to put the brakes on to get it to stop. You have to make it stop. An object at rest tends to stay at rest. So if there's something sitting on a table, it doesn't just suddenly move for no reason, right? If something moves, you tend to think, well, something caused it to move. Okay? That's the gist of Newton's first law. It has another name as well. It's also called the law of inertia. Okay, inertia might be a new word, but it's just a different. It's a more maybe scientific word or technical term for momentum. Okay, momentum. Most people sort of have a general idea of what momentum is. If something has a lot of momentum, then it is hard to stop. Something moving, a bus, driving down the highway. It's very hard to stop. It would take a lot of force for something to stop it, and that might get you the idea of what this is all about. In the same way, something really heavy that's sitting there is hard to get moving. It takes a lot more work to get something moving. It takes a bigger push. To illustrate Newton's first law, we're going to look at a car, and here is an absolutely stunning illustration of a car, if I may say so myself. Now, imagine you're smiling and driving along in your beautiful hand-drawn car. Well, when you first start moving in your car, let's say you're sitting still and you hit that accelerator, okay, and you start moving forwards, right? What tends to happen is you feel a backwards. You feel if you didn't have a headrest or a seat back, you would move backwards a little bit, because what's happening is your body is at rest. Say you're at a stop sign or whatever, and you're stopped, and then when you start going, your body is at rest, and the car starts going, your body wants to stay where it was, right? So you feel this sort of backwards push sensation that comes from wanting to stay at rest, right? Same thing if you are moving forwards and you don't feel that forwards or backwards push of the car, because the car is going, you're going at the same speed of the car. It's all like a constant velocity. You're just kind of cruising along. But then if you hit the brakes, okay, and you stop, your body wants to keep moving because it was in motion, and it tends to want to stay in motion. So you feel a forwards, sensation. That's why we have seat belts. So if you stop really fast, you don't hit the steering wheel or the front of the car or the seat in front of you or something like that. Okay. Now that's Newton's first law in action. Okay. Now I want to address something that people might be thinking. We summarize Newton's first law with these two statements: an object in motion tends to stay in motion, an object in rest tends to stay at rest. Hopefully you've seen how that works in this illustration. Okay. But you might be thinking, I don't know if objects in motion tend to stay in motion. We probably, if something's sitting on a table or if something's sitting still, we know that it's not going to move unless it gets pushed, right? But usually when we say roll something forward, or if, say, a car starts moving, if it's on a flat road and you're not pressing the accelerator, eventually it's going to slow down and stop, right? Or you roll a ball on the floor, it doesn't just keep rolling forever, okay? Usually, even if it doesn't hit something, somebody doesn't stop it, it will slow down. So why is that? So we want to ask ourselves, why do things tend to slow down? The reason is because, like in that first definition, it says an unbalanced force. That's the key to why in our experience, we tend to see things slowing down, and we throw something, it doesn't just go forever. It drops and eventually stops, right? So why is that? Well, we need to understand what this whole phrase about an unbalanced force, what that means. And so in order to understand that, we need to talk about forces and what forces are. So we are going to have a little introduction to forces. And a force, to define what forces are, it's a push or a pull on one object as a result of an interaction with another object. Okay, so a push, a pull, a hit, or whatever. It's an action that you do, that you take, or that something happens. Two things bumping into each other, and that kind of thing. You get a push or a pull, and from these two things interacting. Forces like velocity, like acceleration, and all that, they have units we can measure. Some forces are stronger than others, and we measure force in what's called newtons, named after Isaac Newton, who came up with these laws, that first law that we've just talked about. Now, to illustrate forces, once again, we have our amazing car. Okay, this time it's on the road, and when a car is driving, there are a number of forces acting on it, okay, to get it moving, to keep it moving, to stop it, and stuff like that, okay? And this will give us a good summary of kind of how forces work and what they look like and how we can kind of illustrate them. So first of all, there's the force that makes it go, okay? So that is called thrust, okay? With a car, you could call it a push or something like that, but with rockets and vehicles and anything like that, we usually call like a force that causes something to move. We call it thrust. Okay, now the thrust for a car is created by the engine, but it is transferred through all the gears and axles and everything to the wheels, which push on the road. Okay, now that might seem funny, but if you think about it, when the wheels turn, it's causing a push on the road, which makes the car go in the direction that it wants to, right? That's the thrust. Okay, now acting against the thrust, there's forces going the other way, okay? And those we call resistance forces. They push against the movement. There's an E missing on the word movement. I'll just squeeze it in, okay? They push against that movement. And like I was saying, there's two most common types of resistance, and that is air resistance and friction. Okay, now air resistance, if you put your hand out the window of a moving car, you felt air resistance. That pushes the whole car, experiences that, and it slows it down. If there wasn't air resistance, the car would go faster and things like that. The friction is a little trickier to understand in a car. There's friction all over the place. There's friction between the wheels and the road, and there's frictions in all the moving parts throughout the car that work against that movement, make it harder for the car to push and go forwards. Okay. Now, these resistance forces are what cause things to slow down when it seems like nothing is acting on them, but those air resistance and friction is always there. So if you take your foot off the accelerator, or if you roll a ball and just don't touch it, there will be friction and air resistance that will eventually bring it to a stop, because the thrust, the thing that got it going, is no longer acting on it. Now, you might think there's the thrust and the resistance, that's it, but there's actually there's more forces going on here. There is the weight of the car, right? The weight, everything pretty much has a downward, anything that's not sort of floating in space has a downward force pushing it down due to its mass and due to gravity. Okay, so it's pushing down on the road, and the road is pushing back up on the car. Okay, the car is not going down, it's not falling down due to its weight. It's on the road is supporting it, and it's in effect, the road is pushing back up on the car. Now, the car's not flying up in the air or going down to the ground. So those two forces, what we say is they are balanced. The car sits on the road nicely because they're balanced. But the thrust and the resistance, sometimes they're balanced and sometimes they're not. So let's talk about that. If the thrust is greater than the resistance, then what happens is the car will accelerate in the direction of the thrust. Okay? So when you press on the accelerator, you are you're making the engine turn, and the engine is putting a force that is greater than that resistance, and so it speeds up. Okay? If the resistance is greater than the thrust, then it will accelerate in the opposite direction. What that usually means is it's going to slow down. Okay? But accelerating in the opposite direction, if you're going forwards and you're accelerating backwards, which sounds confusing, it really just means you're slowing down, right? Okay? That's pretty much what that means, slowing down. Now, the thrust can also be equal to the resistance, okay? Which means we have a constant velocity. All right, so when you're, say you set the cruise control or something, or you just hold your foot on the accelerator just enough so that you maintain that speed. Say you're on the highway, freeway, whatever, going 100 k's an hour, 60 miles an hour, or whatever. The thrust from the engine is balanced with those air resistance and friction and any other little resistance forces, which keeps you moving steadily. The same thing can happen. The same thing is true when you're not moving at all, right? I don't know. Oops, where my end bracket or parenthesis went. I'll just chuck that on there real quick. So when you're not moving, there's no thrust and there is no resistance, and that's equals 0 equals 0, right? So it doesn't move. And when they're not balanced, we can calculate the net force, okay? We can take the difference between, the force in one direction versus the force in the other direction. We can basically subtract one from the other and find the net force. So we might have an object, maybe it's just a box and somebody's pushing on it or whatever, and we might have a 10 Newton force pulling it, right? Don't worry about how we measure that. We'll just imagine we know that it's a 10 Newton force, okay? And let's say there's friction or some resistance that's 5 newtons, okay? Well, what's the total force on the object? Well, the net force is the difference, so we take 10 minus 5. So the net force is 5 newtons, and we need to include the direction on that. So we say we can do like an arrow or say to the right or whatever it may be. The 10 Newton force was to the right. That's the stronger one, so it's going to win out. The overall force is to the right. All right, that's it for today. Newton's first law and forces. There's plenty more on this, so look for more videos, Newton's other laws, and some more stuff on forces. I'll talk to you then.